Hello everyone, welcome to the class of quadratic equations exercise 5.4 of class 10 ICSE board. In the previous class we have already discussed the nature of roots, and the class was based on formula method to find the solution of a quadratic equation. In this class we are going to solve questions based on the nature of roots. Now if you go back and see my previous class, you'll understand that the nature of roots depends on the value of t, whether it is greater than 0 or that's equal to 0, or d greater than 0 or d less than 0. So if d is equal to 0, we have both the roots real and equal, and if d is greater than 0, so both the roots are distinct and real. So they are different and they are real. And what happens is, when you have d less than 0, root over d is not possible in that case for your class, and but you have both the roots are imaginary, so you are not going to find solution in that case. You are going to write the roots are imaginary and leave it as it is. So let's move on and solve some questions. So the first question, we have 16x square minus 40x plus 25. So we can say this is the general form of a quadratic equation. So a is 16, b is minus 40, and c is 25. So find the discriminant. You have to find the discriminant and hence find the nature of the roots. So first of all, we know that to find the nature of the roots we need the value of the discriminant. So what is discriminant here? D equals to b square minus 4ac. Just put the values. So b square is minus 40 square, minus 4a is 16, and c is 25, and hence, so square of a minus number, it will be positive. So 4 into 4 1600, minus, you can say 4 into 2500 into 16, it's 1600. So d is actually equals to 0 here. What are the nature of the roots then? So when d is equal to 0, we have both the roots are real and equal. So you can write therefore, as d is greater than, that's equal to 0, right? As d is equal to 0, so roots are real and equal. So the thing is, you're just going to find out whether it is equal to 0 or more or less than 0. So depending on that, you are going to write the nature of the roots. In this question, you have again I've chosen this because there is a different sign. You have minus sign here, you have plus sign here. It doesn't matter because the formula is b square minus 4ac. So you're going to find d equals to b square minus 4ac, and that's b square is 15 square minus 4 into a is 2, and c a is 2 and c is 30. So that comes to 15 square is 225, minus 4 into 2 8, or 4 into 30 is 120, 120 into 2 240. So 240. So that's something minus, you are subtracting a larger number from the smaller one, so minus 15, and as d is what we have, less than 0, right? So d is less than 0, hence roots are imaginary. Here both roots, right? Both the roots are real and equal. Here both the roots are imaginary. Or not real. You can write that no real roots. This question I've solved it for you. Just check the nature of the roots. So you're going to just check the nature of the roots. For that case, you need the value of the discriminant. So D is just putting the values: b square minus 4ac, b is minus 5, a is 2 root 3, and c is root 3. So minus 5 square, this is 4ac, and that's 25, and 4 into 2 8, root 3 into 3 root 3 is 3. So that comes to 1. That means D is greater than 0. So if D is greater than 0, what are the nature of the roots then? The roots are real and unequal. So when D is greater than 0, they are unequal. Okay. In this question, they are asking you to solve the quadratic equation. Without solving, there is this part you have to see. Without solving the quadratic equation, you have to find the value. A constant p here with which value you are going to find out. Okay. So for which the given quadratic equation have real and equal roots. So when do we have that? When the discriminant value is equal to 0. So we just need to put the values of b, that's p minus 3 whole square, 4, a is 1, and c is p. So putting the values, you get then a square plus b square, 3 square is 9, minus 2 into p3 6p. Here you have minus 4p equals to 0. So that's p square, then minus 6p minus 4p minus 10p plus 9 equals to 0. Okay, so we can continue here. So the factors of 9, which when added gives you 10. So that's 9 into 1, right? 9 plus 1 is 10. So that's easy. P square minus 9 p minus p plus 9 equals to 0. So you have p into p minus 9 minus 1 into p minus 9. So p minus 9 into p minus 1 equals to 0. So either p equals to 9 or p equals to 1. When we put separately p minus 9 equals to 0, that means p equals to 9 or p equals to 1. So these are the values of p when the roots are real and equal. In this question, you have to find the value of k for which the quadratic equation has equal roots. So when we have equal roots, when d is equal to 0. Okay, in that case you have the roots are equal. So b square minus 4ac, putting the value, b is minus 2k. Okay, and a is 1, and c is this whole thing, because there is no x, so this whole thing has to be c. Okay, so b square minus 4 into 1, and this is c. So after solving this, you get this equation 4k square minus 28k plus 48 equals to 0. Now this is again a quadratic equation, but you need to find the value of k, so you have to solve it anyway. So after splitting the middle term, I found 16 into 12 is 4 into 48, and 16 plus 12 is minus 28. Okay, so after finding the values of k, that's 4 and 3, 12 by 4 is 3. So after finding the value of k, you are going to find the value of the, when you put the value of k in the equation, we get say when k is 3, we have this equation. So after solving this, you get also when k equals to 3, so when k equals to 3, also the value of the roots, this is k, value of both the roots are also 3. Okay, so after solving this, you get 3 are the roots when k equals to 3. And in the same manner, when k is equal to 4, putting the value 4 in place of k, so equation x square minus 8x plus 16 equals to 0, and then on solving this you get x equals to 4. Both roots are equal when k equals to 4. So when k equals to 4, you have x equals to 4 and 4, and when k equals to 3, also you have both the roots are 3 and 3. In this question, you are going to find the least positive value of k, for which the equation x square plus kx plus 4 is equal to 0 has real roots. Okay, so for real roots, so we have d equals to 0 or d greater than 0. Okay, in both the cases, here the roots are real and equal, here the roots are real and unequal, but we need only the real part. So d is greater than equal to 0, so b square minus 4ac is greater than equal to 0. Now putting the values, b is k here, and a is 1 and c is 4. Okay, putting the values, we get k square minus 16 is greater than equal to 0, k square equals to 16, so we have k greater than equals to plus minus 4. Now since we need the positive values of k, so we are going to discard the negative ones, and considering the positive values of k, we get k greater than equal to 4, and hence the least positive value of k is 4 for the roots to be real. Okay, so that's the solution for the given question. So that's all for now in this class. We have solved questions based on nature of roots. In the upcoming classes, we're going to see some more problems based on quadratic equations. So stay tuned, and thank you. See you in the next class.